This is the Joint Entrance Main Physics Question Paper 2019. So, this paper is hard, but we are trying to solve this question paper as easy as possible. So, in this question, a capacitor is made of two square plates of side A separated by a distance d. This figure is given in this question, but it is not here. I draw this. This is the two plates. This is the two plates. These two plates. And this is A. This is the side A. And this is D. The distance between the plates is D. And the medium and the lower triangular portion is filled with a dielectric of dielectric constant K. The lower triangular portion is filled with a dielectric of dielectric constant K. This is the dielectric. This is the dielectric medium. Dielectric medium. So, here we consider a small area. We consider a small area on the plates dx at a distance x from one side, and suppose this is y. Perpendicular distance is y and horizontal distance is x. We suppose this the area of small portion is dx. So we can write from this y by x is equals to d by a. We can write the perpendicular portion y by x by horizontal portion is equals to d by a. So y equals to d by a into x. This is the perpendicular portion y. So dy equals to d by a dx. As d and a is constant, so dy equals to d by a into dx. So we can write the small change in dc, small change in capacitor 1 by dc is equals to y by k epsilon 0 a into d x. Here k is the dielectric medium in the dielectric constant of the dielectric medium in this lower triangle. So this is y by k epsilon 0 a into d. Here a into d into x. And for this portion we can written it as d minus y divided by epsilon 0 a d x, where a into d is the area of this portion, where a into d is the area of this portion. And here, as we considered the small change in capacitance, so we take the x into this, a into d into this. This is the area, a into d is the area of this portion. So, as there is no dielectric medium, so we can write only this by epsilon 0. This is the free space permittivity. This is the free space permittivity epsilon 0 a dx, and there is also a dielectric medium, so we write y by this y by k epsilon 0 a dx. Then we can write this 1 by dc if we this 1 by epsilon 0 a dx, taking the common from these two, then we can write it as y by x plus d minus y. So taking the integration over dc is equal to epsilon 0 a dx divided by y by x plus d minus 1. This is the integration of dc. So c equals to epsilon 0 a into a by d integration over 0 to d. As d is the distance separated by a distance between two plates, so we have for the capacitance integration over 0 to d dy divided by d plus y into 1 by k minus 1.